2, 3, action. I'm also going to make the official announcement for Railgun version 1.1. So these are the features I'm going to be including in Railgun version 1.1. Better batteries, 7.4 volt, 6 amp hour batteries, an input capacitor, soft start current sensing, better and more efficient rails, and a 40 watt 62 kilohertz split phase pulse width modulated current sensing soft start full bridge capacitor charger. Well, that was quite a lot. In my defense, it's been almost 2 years. I've changed. My plans for the Railgun has changed. And first things first, it's no longer called Railgun version 1.1. I've decided to call it 2.0. Number one, because of public pressure. I think a few of my personal friends would understand that. And number two, I've made enough changes to the design to warrant a completely new number, the number 2, to differentiate it from my original Railgun project. So I even have my original notes from that day, and I think I can contradict almost every single thing I said back then. The name of the capacitor charger, for instance, it's only 30 watts now, which is plenty for 30 joules. It charges in about 1 second. It's not split phase. It does not operate at 62 kilohertz. It's not PWM. Well, at least I don't think you could call it PWM in the traditional sense. It's a continuous mode capacitor charger. I've explained enough in other videos. Soft start, no full bridge, definitely not. It's a flyback. Steps to increase efficiency, like I listed out 2 years back. Input capacitor and soft start, no. Current sensing, in a way, I sense current on the secondary side of the transformer now. Better rails. I don't think I'd call these rails any better. They are just more modular and slightly bigger than what I'd originally planned. So what do I have to show for myself? Alright, so this is the setup everybody's been wanting to see. This is the Railgun as of right now. Let me go through all the parts one by one. Alright, so this is the cap charger. Enough has been said about this thing. The more observant of my viewers would have noticed that I've replaced the potentiometers with 2 fixed resistors, since I don't have place for potentiometers in my PCB, and I've also broken off the switch, so I have to short these 2 wires to get the thing charged. This is a trigger board. The job of this board is to turn on these SCRs as quickly as possible, a nice sharp gate pulse, so that the fall time of the SCRs is very small, so that they don't blow up due to the currents passing through them. And the way this board works is, it charges up a capacitor using an isolated battery and dumps the charge in the capacitor as quickly as possible through this power MOSFET rated for 50 amps. The gate of this MOSFET is driven by a 555 timer. Not optimal. I'll be using an Arduino and an optocoupler for the next version. And this is the Scr Bank, and it's connected in such a way so that all the SCRs, I hope, share the current equally among themselves. Alright, let's do a test shot. I'm going to try and vaporize this bit of aluminium foil. I hope the results are dramatic, because this is the first time I'm trying this out using the new thicker wires, 22 AWG. So I connect the battery. I always have a voltage monitor on this battery in case something goes wrong. Connected, 11.8 volts, that should be enough. I make sure that these wires do not touch each other. I turn the main power on, short these 2 wires, charged, and 3, 2, 1. Okay, that was not very dramatic. A little bit of smoke. Let's try again. And in 3, 2, 1. Not so much. One last time. And 3, 2, 1. Yes, third time lucky. Okay, that was quite a test shot. And between that test shot and May 2018, when I uploaded my second capacitor charger video, I've been doing a lot of these so-called material science experiments. I call them material science because I study the properties of my rails, the defective rails, that is the one with 2 holes in them which I cannot use. I did a wide variety of experiments exploring different materials and contact between the rails and the copper braid, graphite powder. I even created some kind of a conductive paste using Vaseline and graphite. What I did not realize was that it was an explosive mixture. So that was quite a disaster. Anyways, I've included a compilation of all of those tests, and before that a small time lapse of me setting the whole thing up. One. One.
ஸ்கூல் ஒர்க்லாம் ரொம்ப இல்லையா படிக்கிறதுக்கு? அன்னைக்கு சைக்கிள் டெஸ்ட் இல்ல கிளாஸ்ல சார் போடுறதில்ல ப்ராப்ளம்ஸ்லாம்
போடுறோமே.
இங்க கிளாஸ்ல
0. As a result of those experiments, I've also been able to develop a few new kinds of projectiles, which I'll show you right now. This is the first kind of projectile, and as you can see, it's 3 layers of railgun goodness. The middle layer is just solder wick that's been completely coated with solder to make it somewhat stiff and act like a spring, and that has been sandwiched between two regular layers of copper braids. This is a used projectile. So I developed this to have better contact with the rails. The inner layer pushes against the rails, so it kind of acts like a spring. And this is a more traditional kind of a railgun projectile. Copper braid, or well, as other people use, copper wire sandwiched between 2 layers of acrylic. 3 actually. Never tested this one. And also I developed a method to coat graphite onto rails. I just use a pencil lead and a very high current power supply, as you can see. Well, that's all I have to show for you today till the cap charger and trigger board PCBs arrive. Or do I?